In this question, you can see that there is a uncharged soap bubble whose radius is r1 initially, and it is electrified. Due to the charge on the surface of soap bubble, which is uniformly distributed on the surface, the bubble expands and its radius becomes r2 and the potential becomes V. If P0 is the atmospheric pressure of the surroundings of the soap bubble and T is the surface tension of the soap solution, then we have to find out the pressure inside the in fact we have to find out the potential of the soap bubble after electrification, assuming the fact that the pressure inside the soap bubble after electrification is P0. Okay, and let us see the situation that if there is a soap bubble, this is a soap bubble whose radius was initially r1 and the pressure inside was P0 plus Pxs. Now finally, when we have electrified the soap bubble, its radius has changed to r2, and due to the electrification of soap bubble, the inside pressure has become P0, which means that this electric pressure, which is sigma square by 2 epsilon naught, is being balanced with the surface tension force. And we know that the surface tension force is on a half soap bubble, surface tension force will be 4T into 2 pi r, in fact 2T into 2 pi r, and that is equal to this is the force, and that is equal to x, this pressure, sigma square by 2 epsilon naught into pi r square. Cancelling pi with pi, r with r, sigma is equal to 8T into epsilon naught by r under root, and V is sigma r by epsilon naught. So V will be equal to this under root of 8 RT by epsilon naught, and R is R2 obviously, because after electrification the radius of the bubble is R2. So the correct answer is B. Now we move on the next question. In this question you can see that there are two electric dipoles, and these dipole consist of two equal charges which are opposite in sign, and they are placed on insulating rod of length D. These dipoles are placed on x-axis at a large distance r apart from each other. So first of all, let us see that we have to find out the analysis on the left dipole, this one. So we know that the dipole moment of this right one is in the downward direction, and therefore electric field due to this is in the upward direction, and the force acting on the plus charge will be on the upward direction, while the force acting on the minus charge will be in the downward direction. Now force acting on the plus would be greater than the force acting on the minus, due to the fact that force this plus charge is nearer to this dipole, so electric field would be greater on this plus charge. So you can see that a net force is developed on this dipole in the upward direction, and it will try to rotate anti-clockwise. So the correct answer would be that the dipole on the left will feel a force in the upward direction, and the torque which is trying to rotate it counterclockwise. So answer is B. Now we move on the next question. In this question you can see that there is a small charged sphere of mass m and charge q. It is connected by a light inextensible rope string which is non-conducting also. Its length is L, and it is fixed at a point P which has a coordinates of 0, 2L. Now this sphere is at rest in equilibrium position at A, and this sphere is on a horizontal frictionless surface which is xy plane. Okay, so we have given a velocity to this sphere at this point A in the direction of x-axis u I cap, and there is an infinitely long line charge of linear charge density lambda which is placed along the x-axis. we have to find out the instantaneous tension in the string at the instant when the sphere is at point A. So obviously this is a quite easy situation, that we know that if we have given this velocity u, then there would be a centrifugal force which is mu square by L, and L is the length of the rope, and it is being balanced by the pseudo force applied by this infinitely long linear charge. Okay, in fact it is this electric force would be acting in this direction, so F electric would be equal to QE, and E will be equal to 2k lambda by R, so it would be Q into 2k lambda by R. Now R at this position will be 3L. Okay, 3L. So the tension in the rope will be mu square by L plus 2k lambda q by 3L. So you can substitute the value of k as 1 upon 4 pi epsilon naught, so it would be mu square by L plus k, in fact, lambda q by 6 pi epsilon naught L. So the correct answer of this question would be C. Now we move on the next question. In this question, you can see that there are three identical small electric dipoles which are arranged parallel to each other. Each dipole is pointing towards y-axis, positive y-axis, and the distance between each dipole is a. If their total interaction energy is u, and now one of the dipole from any one which is placed at the ends is gradually reversed, and we have to find out the work done by the electric forces. So first of all, we know that u initially would be the sum of u1 plus u2, where u1 would be the interaction energy of these two plus these two. So we can say that interaction energy will be twice of. Now we know that interaction energy of dipole is minus p dot e, okay, and the electric field of this dipole on this dipole would be in the downward direction, because the dipole moment is in the upward direction. So the electric field would be in the downward direction, and this dipole moment is in the upward direction. So the angle between E and P is 180 degree. So U1 will be equal to twice of P into E, where E is the electric field on the equatorial point. So equatorial point electric field is K P by R cube. So U1 will be equal to 2k P square by A cube. And U2 would be the interaction energy of these two dipoles, these two. So in this case it would be again P into K P by, the distance is 2a, so it would be 8a cube. So U2 will be equal to kp square by 8a cube. So U initially will be equal to 1 by 8 plus 2, which is 17 by 8 kp by a cube, first equation. Now in the second case, if we have gradually reversed any one dipole, so let us find out the work done. So let us see the situation that if we have reversed any one dipole, this one, like that, so the interaction energy U final will be equal to, this energy will remain the same, so it would be kp square by a cube, and this energy would be now negative of kp square by a cube, and this energy would also be the negative of minus of kp square by 8a cube. So U final will be equal to minus kp square by 8a cube. Okay, so work done by electric forces is, we know that work done by electric forces will be equal to U initial minus U final. Okay, so U initial is 17 by 8 kp by a cube. This is 17 by 8 kp by a, in fact kp square by a cube. This is kp square. Okay, so and minus of minus kp square by 8a cube. So you can see that it would be equal to 18 kp square by 8a cube. Substitute the value of u in terms of u. So we know that kp square by a cube is 8u by 17. So it will be equal to 18 by 8 into 8u by 17. So it will be equal to 18u by 17. So the correct answer will be option number D. Now we move on the next question. In this question, you can see that there is an electric field in xy plane which is given by xi cap plus yj cap, and the potential at point 2 comma t2 is 0. Then we have to choose the correct options. We know that E is given as 2i cap plus 2j cap, in fact xi cap plus yj cap, and we know that dv is equal to minus E dot dr. We are integrating both the sides, and it is given that potential is 0 at the point 2 comma 2. So applying the limit from 0 to v and 2 comma 2 to x comma y. So v minus 0 is equal to minus of integration E is xi cap plus yj cap dot with dx I cap plus dyj cap. Okay, so v is equal to minus integration x square by 2 plus y square by 2. Okay, we have already done the integration. Now we have to put the limit. So limit is 2 comma 2 to x comma y. So v will be equal to 4 minus x square plus y square by 2. So first of all, you can see that equipotential surface is a circle whose center is origin. So A is wrong. And you can also see that the maximum value of this function is 4. So V max can be 4 when x is 0 and y is 0. So moving away from the origin in the direction of electric field, potential will decrease, and potential is maximum at origin, which is 4. So it cannot exceed 4. So B is correct. The work done in moving a test charge slowly from a point A comma B to B comma A is 0. You can see that if you substitute the value of x as A and y as B in this equation, and y as B and y as A and x as B in this equation, then potential of these 2 points would be same. You can keep the value and you can check, and therefore the work done would be 0. And the fourth option, that x plus y is equal to c, all the points which are lying on this line where c is greater than 0 will have negative potential. We already know that the equipotential surface is a circle whose radius is 2 root 2. So if you see that there is a point which is having the 0 potential, this potential is 0, and this potential is V barabar 4, and electric field is pointing in the outward direction, which means that when we will start to move from origin in the direction of electric field, then potential will decrease. So if we draw a line, this one, x plus y is equal to c, and if we wish to know that whether this point 2 comma 2 is satisfying this equation or not. So let us put 2 comma 2 in this equation and let us see that C is equal to 4. But C is obviously greater than 4, which means that this line would be going from outside this circle. So in the region outside this circle, the potential would be negative, and therefore D option is also correct. So the correct answer of this question is B, C and D. Now we move on the next question. In this question, we have to choose the correct alternatives. The first option says that a conducting body with a total negative charge may have negative, positive or zero potential. See, obviously it is simple to say that let us suppose there is a spherical shell whose charge is minus q and radius is r, and there is a charge capital Q where capital Q is very greater than minus q in magnitude. So the potential of this capital Q on the shell would be positive, and the magnitude of potential of this capital Q would be greater than the magnitude of potential of this Q. So we can say the net potential of this shell would be positive, and if the potential due to this capital Q and due to this minus q is equal in magnitude, then the net potential on this shell would be 0. So we can say that A option is correct. The B option says that when a total charge is distributed on two isolated conducting spheres in such a way such that the total electrical potential energy of the system is minimum, then there will be no charge that will flow when two spheres are connected by the conducting wire. Obviously, we know that if two spheres are connected by a conducting wire, then charge will flow from higher potential to the lower potential, and this is an automatic process which is a self-occurring process. So any self-occurring process always occurs to minimize the potential energy and to gain the stability. So we can say that if potential energy of the system is already minimum, then obviously on connecting the spheres no charge will flow from one sphere to another sphere. So B is also correct. Now C option says that a ring that contains a non-uniformly distributed charge, positive and negative charge. So there are charges plus and minus, non-uniformly distributed, and and on the axis at any point you can see that the electric field due to this one is in the downward direction and due to this one is in this direction. So if these electric fields are not equal, then we can say that one of the component would be along the axis and one would be perpendicular to the axis. But you know that it is given in the question that the magnitude of these charges is same. So we can say that the component of the electric field which is along the axis, which is k q x by x square plus a square to the power 3 by 2, will be 0 because q net is 0. So this is the electric field along the axis. So we can say that if the net charge of the ring is 0, then the axial electric field will be 0, but the electric field could be perpendicular to the axis at any point. So C is also correct. And D option says that a positive charge always moves from higher potential to lower potential. It is wrong because if we have projected any positive charge from lower to higher potential, then it can move from lower to higher potential. So D is also wrong. So the correct answers are A, B and C. Now we move on the next question. In this question, you can see that there is a region in the space that contain a total positive charge Q, and this charge is spherically distributed in the region in such a way such that the volume charge density rho is equal to alpha for r is less than r by 2, and it is equal to 2 alpha into 1 minus r by r for r between r by 2 and r, and it is 0 for r beyond r. So we know that that Q enclosed in the region from 0 to r by 2 can be calculated by integration 4 pi r square dr into rho. Rho is alpha. So limit would be from 0 to r by 2. So this will be 4 by 3 pi alpha r cube, and limit would be from 0 to r by 2. So q inside in this region would be equal to 4 by 3 pi alpha r cube by 8. So this will be pi alpha r cube by 6. Okay, so so option C is correct, obviously. And the q inside in the region r by 2 to r will be equal to 4 pi r square integration dr into 2 alpha into 1 minus r by r. So taking out common, and limit would be from r by 2 to r. So this will be equal to 4 pi into, in fact this is 8 pi alpha, and this is integration r square minus r cube by r into dr. Limit will be equal to r by 2 to r, and this q inside will be equal to 8 pi alpha, and this will be r cube by 3 and minus r to the power 4 by 4r. Limit would be from 0 to, in fact limit would be from r by 2 to r. So this is r by 2 to r. So q inside will be equal to 8 pi alpha, and putting the limit r, so this is r cube by 3 minus r cube by 4, okay, minus, and this will be r cube by 8 into 3 is 24, and this is minus r to the power 4. R to the power 4 would be r by 16, and there is 4 also in the denominator, so it will be r cube by 64. So q inside will be equal to pi alpha, and this is r this will be 4 minus 3, so it is 1 by 12 r cube, and this is 192, and it would be 3, it would be in fact 8 minus 3. So q inside will be pi, and there would be 8 also, so this is 8 pi alpha 8 pi alpha, and we can take r cube common, and this would be 192, and this would be 16 minus, this is 5. Okay, so 16 minus 5 is 11, and this is alpha into pi into r cube and divided by 24. 192 by 8 is 24, and this is 11. This is q inside in this region. So in this region you can see that this is 11 by 24, so D is also correct. And total charge will be this q inside, which is alpha pi r cube by 24 into 11, plus this charge, which was, I think, alpha pi r cube by 6. This is alpha pi r cube by 6. So it would be 11 plus 4 alpha pi r cube. So it would be 15 by 24, and 15 by 24 will be 5 by 8 alpha pi r cube, and this is q, because total charge which is distributed is q. So option A will be also correct, because alpha will be equal to alpha will be equal to 8q by 5 pi r square r cube. So the correct answers will be A, C and D. Now we move on the next question. In this question you can see that there is a conductor in which solid conductor which is neutral, and this is also isolated, and there is a small cavity inside this conductor. So let us draw the diagram first of all. So this is a conductor, and there is a small cavity inside this conductor. Let us draw the cavity also. This is the cavity, and this is the center C. Okay, now there is a charge. Now option 1 says that if a point charge q is placed inside the cavity but not at the center, then potential of the conductor is this. So let us place a point charge q inside the cavity. Now let us see that there will be a negative induced charge here, and there will be a positive induced charge plus q on the outer surface of the cavity on the conductor. And we know that the potential of the conductor will be the potential at the center C. So we know that the potential due to this q and this minus q will be 0 at this point because they are bounded charges, and outside this periphery the electric field and the electric potential of this bounded charge is 0. So at this point only this potential would be created. So the potential at C will be the potential at conductor, and it would be equal to kq by r. So A option is correct. Q is a small q obviously. So A option is correct. And now if the point charge q is placed at the center of the cavity, then potential of the conductor will be 0. This is also incorrect, because if we place this charge at the center, then the only difference that will occur will be the fact that this negative charge will be uniformly distributed on the inner surface of the cavity, and again the potential due to this q which is at the center and this negative charge induced inside the inner surface would be 0 at C. So at C only potential will be due to this positive charge. So B is also incorrect. Now if the point charge q is placed inside the cavity but not at the center, then the potential of the conductor will be this one. Obviously this is also wrong. And D option, that if a point charge q is placed inside the cavity but not at the center, then the potential at the center of the conductor due to charges on the outer surface of the conductor is this. So obviously you can see that at C point the net potential will be only due to the outer charges, and it is this one only. So the correct answers are A and D. Now let's move on to the next question. In this question you can see that there is a planet of mass m and radius r as shown in the figure, and there is a particle which is projected from the surface of this planet at an angle of theta from the radial direction, and with the velocity v0 which is equal to the orbital velocity at that point. So first of all we know that the formula for orbital velocity is under root gm by r plus h. Now on the surface of this planet h is 0, so v0 will be equal to under root of gm by r. Now we know that we have to find out the maximum height first of all, and then we have to find out the time taken by the particle to return on the planet. Okay, so we know that this particle would go like that, something like that, and at this position when its velocity would be perpendicular to this radius, then at this position the height would be maximum. So let us suppose that this is h and this is r. Okay, so this velocity will be v. Obviously v will change due to the force. Now we know that at any point let's suppose at this point the gravitational force acting on the particle is towards the center of the planet, and therefore the net torque of the gravitational force about the center will be 0, which means that we can conserve the angular momentum about O. So the initial angular momentum about O is equal to, this is m v naught into r sine theta. Okay, this is mv naught r sine theta, and final angular momentum will be mv into r plus h. So balancing these two angular momentums, mv naught r sine theta will be equal to mv into r plus h. Cancelling m with m, so you can see that v will be equal to v naught r sine theta upon r plus h. Okay, this is the first equation. Now in part 2, let us conserve the energy. The energy initially was the energy at this point P, and this energy will be equal to the potential energy. In fact, this energy will be equal to the potential energy of the, in fact we can say that at this point the total energy will be equal to the total energy of the satellite in the orbit of radius r. So we know that the total energy of satellite in orbit of radius r is minus gmm by 2r, and at this point we can say that the energy will be equal to finally half mv square plus the potential, which is minus of gmm by r plus h. So the equation will be initial energy will be equal to the final energy, which is the law of conservation of mechanical energy. So minus gmm by 2r will be equal to half mv square. V square is v naught square r square sine square theta divided by r plus h whole square minus gmm by r plus h. And now we can substitute the value of v naught, which is under root this gm by r, in this equation. So you can see that it would be gmm by 2r, and it would be equal to gmm by r plus h minus this is you can see that v naught is under root gm by r, so we will substitute this value here. So it would be gmm by 2, and this is r square sine square theta, r square sine square theta divided by r plus h whole square, and cancelling gmm with gmm, and there would be a r also, there is r, so cancelling this r with r. So 1 upon 2r will be equal to 1 upon r plus h is common, and here will be 1 minus r sine square theta by 2 r h plus r. So if we solve this will be a equation which is a quadratic equation, and you can in fact it would not be a quadratic equation. This would be easy to solve if you can solve this equation. I'm not solving this equation, I've already solved, and this equation satisfies that h is equal to r cos theta. So this is h. So we can say that the maximum height from the center, maximum distance from the center would be r plus h, which is r plus r cos theta, which is option A. Now we have to find out the time taken by the particle to reach the surface again. So for this case, let us draw the diagram again. Let us see that it was projected like that and it returned like that. So let us consider that this is a obviously we know that this would be a ellipse. The path would be the elliptical, and this distance, this is r, and this is r cos theta, and this complete distance is r plus r cos theta. So this distance, this one, will be equal to r plus r cos theta minus r cos theta, which is r, and this is r sin theta. Okay, so the area of this ellipse is pi ab by 2. This is the area, so area will be equal to pi a is the semi major axis and b is the semi minor axis, so this is r sin theta into r divided by 2. So area will be equal to pi r square sin theta by 2. We also know that the aerial velocity dA by dt is constant and is equal to L by 2m. So dA by dt will be the area covered upon time taken. So pi r square sin theta by 2, pi r square sin theta by 2 upon time taken is t, is equal to angular momentum L, which is m, which was already we have already calculated m v naught r sin theta. So this is m v naught r sin theta divided by 2m. So cancelling m with m, 2 with 2, and we know that this t will be equal to pi r by v naught. So this is pi by pi r by v naught. V naught is gm by r, so this is under root gm by r. So answer would be pi under root r cube by gm. So this is the option number D. So the correct answer of this question is A and D. Now we move on the next question. In this question you can see that there are two thin conducting shells of radii r and 2r respectively. The outer shell carries a charge of q and the inner shell is neutral. We have to choose the correct options. So you know that when switch is open, then the potential of inner sphere will be same as that at a distance of 3r by 2 from the center. We know when switch is open, then only charge on the system will be on the outer shell, which is q, and all the points which are inside this bigger shell will have same potential. So option A is correct. Now when S is closed, the potential of inner sphere will become 0, obviously, because we have grounded it, so potential will become 0. When S is closed, the charge on the inner sphere is minus q by 2. So let us suppose that a charge of qf is flown from the ground on the inner sphere so that its potential will be 0. So k q by, we are writing down the total potential of this inner shell, which would be kq by 2r plus kqf by r, and this would be 0. So qf, you can see that qf would be equal to minus q by 2. So C option is also correct. And when the switch is closed, then the charge on the inner sphere is minus q. This is wrong. So the correct answers are A, B and C. In this question you can see that there is a uniformly charged sphere. This sphere is, and it is placed inside a hollow sphere which is also uniformly charged. The charge on both of them is q, and we have to find out the value of electric field at this point P, which is just outside the hollow sphere. It is very important to note in this question that it is not given that any one of them is conducting. So we cannot assume them conducting. So we have to assume them non-conducting, and as they are non-conducting, we can assume that there would be no induced charge. So first of all, let us write down the electric field of this one. Let us see that this radius will be equal to 2. So electric field of this smaller sphere will be kq by 1 square, and electric field due to this hollow sphere would be kq by 2 square, because its radius is 2. This angle is 60, this angle is 60. So let us write it as this is kq by 4 and this is kq. So if it is E, then it is 4E. So the net electric field at the point P will be under root E square plus 16 E square plus 2 into 4E into 1 by 2. So this will be under root of 21E, and under root of 21E is equal to kq by 4. So k is 9 into 10 raised to power 9 by 4, and q is 4 under root 3 by 7. Cancelling this 4 with 4, this root 7 with this root 21, this would be root 3, and this is 3 into 9 into 10 raised to power. There will be a microcoulomb also, so 10 raised to power 3, and this is equal to 3 alpha kilo Newton per coulomb. So this is cancelled, so alpha is equal to 9. So the correct answer is 9. Now let's move on the next question. In this question, you can see that there are two wires. One wire is along a line which is parallel to x-axis, and other wire is along a line which is parallel to z-axis. These two wires are infinitely long wires, and they are given a charge density of lambda 1 and lambda 2. Now we have to find out the value of n, where F is the force acting between these two wires. See, we do not have to solve this force by integrating. We just can use the common sense that we know that the force formula, or the dimensionally force, is k q1 q2 by r square. So 1 upon 4 pi epsilon naught and q1 q2 by r square, this is the force. So you can see that lambda 1 has a dimension of q by l, lambda 2 has a dimension of q by l. Therefore r to the power n will be 1 and n will be 0. You can check this by dimensional analysis. So the correct answer is 0. Now we move on the next question. In this question, you can see that there is a binary star system which is revolving, in which there are two stars which are revolving around their common center of mass. The masses of star A and star B are given. So let us suppose that mass of star A is m and that of star B will be 3m. And we have to find out the ratio of area swept by the star A to the area swept by the star B in the common time interval. So we know that, let's suppose that this is R and this is capital R. This is capital R. So we know that mass movement about center of mass is 0. So 3m into R will be equal to m into capital R. So capital R will be 3R, first of all. Now second thing, we know that the area swept in the common time interval is dA by dt, dA1 by dt will be L1 by 2m1, and dA2 by dt will be L2 by 2m2. So dA1 by dA2 will be equal to L1 by L2 into m2 by m1, and you can see that L is mVr, so m1 v into v1 into r1 upon m1 into m2 upon m2 v2 r2. Cancelling m1 with m1, m2 with m2, we have to find out v1 r1 upon v2 r2. We know that v will be equal to r omega. So this is r1 square omega and r2 square omega, and omega is same. So actually we have to find out the r1 square by r2 square. So this ratio will be obviously equal to 9, because this is 3:1. So correct answer is 9. Now let's move on the next question. In this question, you can see that there is a small sphere of mass m, where m is 0.6 kg. It carries a positive charge q, which is 80 microcoulomb, and it is connected with a light inextensible flexible string of length 30 centimeters. This mass is whirled in a vertical circle, and there is a electric field that exists in the horizontal direction towards left, and we have to find out the minimum velocity required by the sphere at the top point so that it completes the vertical circle. First of all, let us draw the diagram. Let us see that in the equilibrium position, when the sphere would be at rest, the angle made by the sphere would be theta from the vertical, and this is due to the fact that there would be a force QE and mg acting in the downward direction. So we know that this angle is theta, and tan theta will be equal to QE by mg. Okay, now Q is 80 into 10 raised to power minus 6, E is 10 raised to power minus 5, mg is 6, so this is 4 by 3, and theta will be equal to 53 degree. Okay, now we can also find out the G effective. So G effective can be calculated as QE cos 37 plus mg cos 53 by m. So QE is 8. So 8 into cos 37 is 4 by 5, plus mg is 6, and cos 53 is 3 by 5, divided by m is 0.6. So this is 32 plus 18 by 5. So 32 plus 18 would be 50 by 5, which is 10, and this would be 100 by 6. So we can say that G effective will be 50 by 3. This is G effective. Now this is the one thing. Now we know that in vertical circular motion, let us draw the diagram again. Let us eliminate the electric field and let us assume that in this vertical circular motion, where there is no electric field, only mg is present, then at this point, which is at an angle of 53 degree, like that, because if we rotate this question in counterclockwise direction by 53 degree, then this line will become vertical and this line will tilt. Okay, so this is 53. Now we have to find out the velocity at this point. So we can easily say that at top point the energy is equal to total energy of the vertical circular motion is equal to at any point it is equal to E is equal to 5 by 2 mgl, and this height is equal to L plus L cos 53. So this is L plus L into cos 53 is 3 by 5. So this is 8L by 5. So E is equal to 5 by 2 mg into 8L by 5. 8L by 5. So this is 4 mgl. E is 4 mgl. And at this position, obviously, we have let us first of all see that this height is 8L by 5. Okay, now at this position total energy would be equal to this one, and at this position, let's suppose velocity is v, so the total energy at this position will be half mv square plus this height is 8L by 5, so mg into 8L by 5, and that would be equal to 5 by 2 mgl. So half mv square will be equal to mgl common, and 5 by 2 minus 8 by 5. So half mv square will be equal to mgl, and LCM is 10, and it is 25 minus 16, and cancelling m with m. So v square is equal to, this is gl into 9 divided by 5. So v will be equal to 3 under root gl by 5. this is G, this is V at this position. Now what we have to do, that in the presence of electric field, this position is similar to this position, so the velocity at this position would be equal to V, which is under root of, we have already calculated, we are let us use next page. So let us use this page. We can see that at this position we have already calculated the situation. This is vertical line and this is the equilibrium line, and this angle is 53 degree. So at this position we have already calculated that V is equal to 3 under root GL by 5. So 3 under root GL by 5. Now we have to use G effective instead of G. So G effective we have already calculated that it is 50 by 3. So V will be equal to 3 under root of 50 by 3 by 5, and L is equal to 0.3 meters. We have to take it in meters. So this is 0.3. So you can see that this is 10 and V will be equal to 3. So the correct answer of this question is 3. Now this is 3. Now let's move on the next question. In this question you can see that there is a rod which is lying like that, and there is a small ring having a charge Q and mass M which is on the rod. It can slide on the rod with no friction, and there is no gravity in the region. So we have to find out that what minimum velocity should we give to this ring so that it just reaches the other end of the rod. So see, this is a conceptual question. You can see that if this is the origin, let us draw the diagram. This is the origin and electric field is this. So let us draw a perpendicular. This angle is 45 degree, so this is a perpendicular. So the coordinate of this point will be this is L, and this would be L by root 2 and this would be L by 2. So the coordinate of this point would be L by 2 comma L by 2. So above this point electric field is like that, so the component of electric field along the rod will be in upward direction E parallel, and below this point electric field is like that, so the component of electric field below the rod will be in the downward direction. So if this charge is just projected from this point in such a way such that it just crosses this point, then automatically it will reach the other end. So we have to project it in such a way such that it just reaches the point B. Okay, now let us find out the potential difference of these 2 points. Now we know that dV is equal to minus E dot dr. So dV is equal to minus integration E naught by L into x dx plus y dy, and integration limit would be from VA to VB, and or we can say that dV is the final potential minus initial potential. So we can also predict that when we are going from A to B, we are going against the electric field, so potential will increase. So this would be let us apply the limits. So this would be from VA to VB, and the distance point would be A to B. So VB minus VA will be obviously we can also apply the limits from VB to VA because we are moving against the electric field. So V final to V initial. Okay, so this is this minus sign is adjusted, and this is VB minus VA, and this is E naught by L, and the integration of this term would be x square by 2 plus y square by 2. Okay, now the limits would be 0 comma L. Limit of point A will be equal to 0 comma L, and limit of point B will be L by 2 to L by 2. Okay, so delta V will be equal to E naught by 2L, and applying the limits, so this would be L square by 4 plus L square by 4, which is L square by 2 minus L square by 2. Okay, because x is 0, in fact minus L square. Okay, so you can see that delta V is equal to E naught by 2L into minus of L square by 2. We can just ignore this minus sign due to the fact that we have to find out the magnitude of kinetic energy. So let us talk about the mod. So delta V would be equal to E naught L by 4, and work done will be equal to Q delta V. So this would be equal to half mv square, where V is the velocity which we have given. So Q into delta V is E naught L by 4 is equal to half mv square. So this is 2. So V square is equal to Q E naught L by m into 2, and V will be equal to root of this. So if we compare it, if we have to find out the velocity, and it is given that Q E naught L by m is 8. So Q E naught L by m is 8. So V is equal to under root of 8 by 2. So it is 4. So answer will be 2. Now let's move on the next question.